Hi everyone, welcome back to the Pre-Cal 40S videos. In this one we're going to look at the definitions for that are in 1.2 for reflections and stretches or compressions. And this covers outcome R2R5. And in this video we're only going to look at reflections. Okay, and then in the next one we'll do stretches and compressions. Okay. So for definitions, a reflection is a mirror image on or over or about the line, called the line of reflection. Okay, so we're either going to be flipping back and forth, kind of like that, either over the y or the x-axis. In stretches and compressions, what we're seeing is it's a transformation where the distance from the line of the reflection is multiplied by a scale factor. So our scale factors are, well, if they're between 0 and 1, it's going to be a compression. So compression is when something gets smaller or squished. And when a scale factor is greater than 1, then it's going to stretch. So it's going to get bigger or longer. All right, and an invariant point is something that's going to be important to us. It's a point that is not affected by the transformation. So if you look at the word invariant, vary means change and in is kind of a negative of it, right? So it does not change. A point that does not move or change, and you could look at it as the point does not change, it remains in the same spot. So wherever it was on the original graph, that's where it's going to be after the transformation. All right, so in this first example, we're going to look at reflection, and this is going to be our original f of x graph. We're going to look at the two following transformations. Now notice here the negative is on the outside of the f of x, so it's going to apply to the entire y values. And this, you've got your negative, it's inside of the bracket, it's in the of x part, so it's going to apply on the x values. If we just look a little more specifically at these guys here, so we'll look at when the negative is out here. What happens? Well, we multiply all values by -1, and you could also look at it as where you have your positive y values, they now become negative, and your negative y values now become positive. And what that looks like on the graph is a reflection over the x-axis. So let's actually do this example and see how it's affected. You can very lightly see the original is given as a dotted line. I'm just going to make that a little bit more pronounced so that I can see it. So for every y value, we're going to look at the y values. So we're going to look at this -1 here. This point here, that's at -1, those are going to become, they're going to reflect over the x-axis. So this is the x-axis and they're flipping up, okay? Now here where we've got y equals 1, that's going to become y equals -1. So it's flipping. And then here we see that this is our y equals 0. Well, y equals 0, 0 multiplied by -1 is going to remain the same. So that's actually one of our invariant points that doesn't change. So just to erase these original ones so we don't get confused, we take our straight edge and we draw the graph of our transformed. Okay, so that's what the graph of that looks like. And for mapping notation, x, y, and the way to get to our transformed version is by multiplying the y by negative. All right? Okay, now let's look at this next. So we've got our y equals f of x, sorry, f of negative x. So any x values now get multiplied by negative 1. And there's another way of looking at it. If you have any positive x values, they now become negative, and any negative x values become positive. And this looks like a reflection over the y-axis. So you're flipping over the y-axis. So this is our y-axis, and we're flipping this way. Okay, so let's take this and let's do that example. So we need to look at all of our x values that are here. So here we've got x equals positive 2. It's going to become negative 2, so that's where this point goes. And then we have x equals 1, that's going to be negative 1. I want to stay exactly the same along the y's. Okay, so this went here, and then now what's my x value here? My x value here is 0. Multiply that by negative 1, it stays the same. And I'm going to look at this x value that I have. It's now going to become a positive 2. Okay, so everything, it flips over the y-axis, so it kind of goes this way. All right, and then we're going to get our straight edge and make our graph like so. All right, and that one in mapping notation, we've got our x and y, and the mapping of that is multiply negative 1 by the x's. Okay, and our y's remain the same. Okay, so that's a very short video just on reflections. So the next one we're going to take care of stretches and compressions, so stay tuned.